The nail clipper was invented in 1896 in the United States, and soon it was at everyone's fingertips. By 1902, ads marketed it as the gem, and it was sold by the dozen for $2 in U.S. currency. As an alternative to scissors, it was an idea that just clicked. More than a century after its invention, the nail clipper is still behind many a well-groomed hand. Its popularity numbers in the millions, and no manicure set would be complete without one. Production begins with this elaborate die. It's about 1 meter in length, and it has 12 different shaped openings. Hydraulic machinery repeatedly forces a steel sheet through the various openings as the sheet moves forward. With each stroke, the parts look more like nail clipper jaws. The clipping edge starts out straight and blunt and gradually becomes concave. The machinery also cuts and shapes the holes for assembling the nail clippers. In just 1 minute, a total of 80 strokes generate a dozen nail clipper jaws. Here, the clipper jaws vibrate with abrasive stones and organic acid for up to 20 hours. This gentle polishing makes the parts gleam, but doesn't ruin the edges and contours. At the next station, a worker aligns pairs of clipper jaws for assembly. Using a mechanical press, he drives a rivet into the hole at the gripping end of the jaws. He flips the assembled clipper jaws over, inserts the other half of the rivet, and then presses the two tightly together. The rivet locks the gripping end of the nail clippers together so that the two jaws can't be twisted apart. Next, a worker smooths the edges of the clipper's gripping end against an abrasive wheel. This grinding evens out any irregularities and makes the two clipper jaws appear as one at the gripping end. Attention now turns to the cutting end of the clippers. After locking them in a device, a worker grinds the concave edges until they match up. These nail clipper jaws are now ready for the lever, but the lever itself still needs some work. Using a little press, they make a hole and an indentation between its two prongs, allowing the lever to sit more comfortably on the clipper. Levers are then fed one at a time to a set of drills that carve little holes into the prongs of the fork. The holes are just big enough for a pin that's 1.3 millimeters in diameter. Here's the view from the side, before and after drilling. A worker now inserts a bolt in the cutting end of the clipper jaws. This bolt has a little hole in the end of it. He presses the jaws together, and it's now time to attach the lever. He inserts the pin in the holes in the lever and the bolt. He pinches the pin with pliers to secure it, and the lever now pivots freely on the cutting jaws. All the pieces of the nail clipper have come together, but the assembly processes have left oil and other residues on this tool. It's time for a cleaning in a special tub. Sound waves keep the water moving to distribute the soap and scrub them clean. Once they dry, a worker uses a combination of acid and positive electrodes to etch the company name and item number onto the nail clipper. The next employee sands the cutting edges to sharpen them. It takes skill and practice to get them just right. He holds the nail clipper to a light and scrutinizes the alignment of the jaws as he opens and closes them. This cardboard test confirms that these nail clippers are up to the job. From a blunt clipper on the left to a really sharp tool on the right, what a difference the sanding has made. The lever swivels for various clipping angles and then folds down neatly when not in use. It takes 11 people to manufacture 100 of these clippers an hour, and that means they've been working at a very fast clip.